Solve the given triangle. So for triangle ABC, we can see we're given two sides and the included angle. This is a side angle side situation. And that is the law of cosines criteria. So we're going to apply the law of cosines first, and then apply the law of sines, and continue to work through solving the triangle. So we want to solve for this side B over here that is opposite from angle B. So here's the law of cosines that's going to apply to this situation. B squared equals a squared plus c squared minus 2ac cosine of b. And I'm using this one because we're trying to solve for the side length b. So let's go ahead and substitute and solve here. B squared we don't know, but all the other information we should know. A squared is going to be 9.6 squared plus c squared, which is 14.1 squared, minus 2 times 9.6 times 14.1, and then times cosine of 65 degrees. Okay, so let's get the calculator and figure this out. So 9.6 squared plus 14.1 squared and then minus, and I'm using parentheses because it's subtracting everything, 2 times 9.6 times 14.1 and then times cosine of 65 degrees. 176.558 is b squared, so I'm just going to say 176.6. So b is going to be the square root of 176.6. So I'm going to do the square root of the answer from the previous line, which is this whole decimal here. So b is going to be 13.287 or 13.3. And again, remember, these are all rounded answers. Okay, so 13.3 for b. Now we need to solve for another angle, but this time we can use the law of sines. So we know the 13.3 and 65 degrees for b, so that's going to be one of the ratios we'll use. So sine of b to side b equals, and let's just go ahead and solve for a. So it'll be sine of a to substitute. Sine of b is a sine of 65 degrees, and side length b is 13.3. Sine of angle A we don't know. Side length A is 9.6. So now we'll cross multiply. 13.3 times the sine of A equals 9.6 times the sine of 65 degrees. So let's simplify the right side. 9.6 times the sine of 65 degrees, 8.7005. So it's 8.7006. That's equal to 13.3 sine of A. Divide both sides by 13.3 to solve for sine of A. So sine of A equals this 8.7006 divided by 13.3. So divided by 13.3. 0.6542. So measure of angle A is the inverse sine of 0.6542. So inverse sine of the decimal in the previous line, 40.857 or 40.9 degrees. Okay, so that's another angle here. And the only item left to solve for is this angle C. And we know the other two angle measures of the triangle, so we can apply the triangle sum theorem at 80 degrees and then subtract the other two angles, 65 degrees and then minus 40.9. That will give us the measure of angle C. .1 degrees. So the measure of angle C equals 74.1 degrees. Okay, so there are three different processes here. The first one, using the law of cosines to solve for the unknown side. Then we use the law of cosines to solve for an unknown angle. And once we had two known angles, we could solve for the third angle using the triangle sum theorem. So law of cosines first, law of sines second, and finally, triangle sum theorem.